All right, so if you remember, our essential question is how can we use Cavalieri's principle to determine volume of 3D figures? So last week we talked about using formulas, straight up formulas of, and we have a formula for cylinder, for sphere, prisms, pyramids, all of that stuff. So now what we're going to do is we're going to use this principle to partner with those formulas to determine volume, okay? So keep that in mind as we're going through this lesson. So first thing, at the top of your page, you should see this goes in your notebook. Mine is correct, 2.6. You need to change yours from 2.5, change that 5 to a 6 so it goes in the correct spot in your notebook. All right, so as we talked about, we're going to talk about Cavalieri's principle. Before that, we're going to just talk about what a cross-section is. So this was one of your defined terms in your organizer that you did on Quizlet. And a cross-section is just an intersection of a plane and a solid. We're talking about a plane in geometry, a flat surface, not an airplane. All right, so these little things down here, these two circles in the cone, and then the two triangles in this triangular pyramid, those are cross sections. Okay, so it's just you cut cross through the three-dimensional figure, and it's just one of the little bitty sections. All right, Cavalieri's principle simply states if two figures have equal bases and equal cross sections at every point, and the heights are the same, then the volumes are equal. So I'm just going to break it down like this. Equal base or cross section plus equal height equals equal volume. Okay? Let's look at just a straightforward example. These two, this is a cone and a triangular pyramid. Okay? This here tells us that the cross sections are equal. So we have equal cross section, and this here tells us that the equal heights are equal. So since we have, looking back up here, equal base or cross section, and we have an equal height, then the volumes are equal. So we just wrote that out. The height of the cone are the same. The two cross sections are equal. Volumes are equal. Okay, so let's look at example 1. If two stacks of pennies below have the same height, okay, what can you say about the volume? We're going to, as a hint, use Cavalieri's principle. Okay, so Cavalieri's principle, equal base plus equal height have equal volume. All right, we know they have the same height. Pennies have the same okay, pennies are going to have equal area. Any penny you get, it's going to be equal. So they have equal areas, and since a penny is the base, we have equal base. So then by Cavalieri's principle equal volume. All right. Another typo in this. This is supposed to say do the stacks of identical parallel discs have the same volume. So it's just asking these two figures here, figure A and figure B, are the volumes equal? Okay. So if I look at it, since they're identical, then area of base are equal. Then, if I go back over here, this is 1, 2, 3, 4, 5, 6, 7. And this is 1, 2, 3, 4, 5, 6, 7. Okay. So the area of bases are equal. Height is equal. Therefore, by Cavalieri's principle, volumes are equal. Okay, so this just tells us whether an object is slanted. So sometimes you have like a slanted cylinder. As long as the height is the same and the area of the base is the same, you're going to use the same formula because the volumes are going to be equal. All right, so next thing, we're going to talk a little bit more about cross sections. So remember, a cross section is just an intersection of a plane and a solid. A cross section is going to be a 2D, two-dimensional shape. So it's going to be squares, rectangles, circles, triangles, everything two-dimensional. Okay, so when I say a vertical cross section, a horizontal cross section, a vertical cross section is going to be perpendicular to the base. A horizontal cross section is going to be parallel to the base. Okay, so you got to remember what your base is. So, a sphere. Sphere is rounded all the way around. I'm going to kind of draw a picture here. It's not going to be great, but sphere is rounded all the way around. So no matter which way you cross it, your cross sections are going to be circles. It's just like if I were to take a piece of Play-Doh, curl it up in a ball, and then take a knife and slice down the middle, what shape would I get? No matter which way I cut it, I'm going to get a circle. Next thing is a triangular pyramid. Okay? Looking back at your definition of triangular pyramids, that is triangles for sides, triangle for base. Okay? So since it's triangles all around, either way you cut it, you're going to have triangles. All right, next up, a square pyramid. So you got sides that are triangles and a base that is square. Okay? So if I know that the base is square and that the sides are triangles, if I cut it parallel to the base, then that's going to give me a square as that cross section. And if I cut it straight up and down, that's going to give me a triangle. So you may notice that the vertical is going to be the shape of the sides, and the horizontal is going to be the shape of the base. All right, so a cone. That's kind of a rough drawing of a cone. I know that if I cut it parallel to the base, if I slice through it that way, I'm going to get a circle because that's still the base. What? And then if I cut it straight up and down, again, I'm going to get a triangle. Okay, next, a triangular prism. Remember, a triangular prism has triangles for bases. Okay, so if that's the case, then the triangle is going to be my horizontal cross section. And that leaves the rectangle as my vertical cross section. And then since everything is rectangles here, both of them are going to be rectangles. All right, last thing. We create three-dimensional shapes by translating and rotating two-dimensional shapes. Okay? So let's think back. A translation is a slide. A rotation is a turn. Okay? Think circle for a rotation. All right, so if I start with a rectangle and I slide it down and I have another rectangle and I were to connect those two, what kind of shape is that? That gives me a rectangular prism. Okay. If I have a rectangle and I rotate it, I turn it, that's going to give me a cylinder. All right, again, if I have a circle and I slide it, that's going to give me a cylinder. If I have a circle and I just turn it, that's going to give me a sphere. Circles, turn it, that gives me more circles, creates a sphere. Last one, a triangle. Slid is a triangular prism. And then a last one, a triangle rotated, would give me a cone.